In this video we're going to look at completing the square. Completing the square is a process for rewriting a quadratic expression. It can be used to solve quadratic equations in cases where the quadratic doesn't factorise. As we have seen, a quadratic expression is something of the form ax squared plus bx plus c. In this video we shall only consider the case where a equals 1. That is, we shall only consider quadratics of the form x squared plus bx plus c. We shall deal with the case where a is not 1 in the next video. So, let's take the quadratic expression x squared plus bx plus c. As I said, we want to rewrite this expression in a different format, so that what we end up with is equal to this original expression, just written in a slightly different way. Whatever we write on the right hand side of this equals sign must equal the left hand expression. Now, the first stage of completing the square is to introduce a bracket like so. We write x plus b over 2 all squared, then we write plus c outside the bracket. We always divide the term in front of the x, which in this case is just b, by 2 when we put it in brackets. We will see why in a minute. So, what we have done here is attempt to write the first part of the quadratic as a square. However, at the moment the two sides are not equal. To see this, we'll times out the bracket using the FOIL method discussed in a previous video. So we have that x plus b over 2 all squared plus c equals x squared plus b over 2x plus b over 2x plus b squared over 4 plus c. Let's rearrange and simplify this. We have x squared plus b over 2x plus b over 2x, which is bx, plus c plus b squared over 4. So we note two things. Firstly, we see why we have to divide b by 2 when we put it in the brackets. Secondly, we see that the brackets give us this extra term b squared over 4. So, on the right hand side, we have to minus the term off, so we write minus b squared over 4 at the end. The two expressions are now equal. The expression on the right is the general form one obtains when they complete the square on a quadratic expression. Hopefully, it is now clear why this process is called completing the square. We first introduce a square, the term in brackets, and then we introduce a new term to complete the square, ensuring our new expression is equal to our original expression. In summary, the process is: divide b by 2 and then add this to x, square this expression, subtract the square of the non-x term in brackets, i.e. subtract b squared over 4, and finally add c. Let's look at an example. We're asked to complete the square for the quadratic equation x squared minus 3x plus 2. We don't have to divide each term by a leading coefficient because x is equal to 1, and dividing by 1 wouldn't change anything. So we can immediately add our bracket. That's x minus 3 over 2 squared plus 2, and the final step is to subtract negative 3 over 2 squared. So we have x minus 3 over 2 squared plus 2 minus 9 over 4. And that's equal to x minus 3 over 2 squared minus 1 over 4. We can carry out a check just to make sure we've completed the square properly. X minus 3 over 2 squared is equal to x squared minus 3x plus 9 over 4. So x minus 3 over 2 squared minus a quarter is x squared minus 3x plus 2 as required.